laser hobbyists. This is Chris in Doha, Qatar. I wanted to show you a nice brass with copper heatsink host that Rich at laserpointerforums.com made for me. He machined the host and I put in the laser diode. This top piece here is a lens guard. He did not make that for me. I found that on eBay just like that at about the right diameter. It's a little tight fitting though, but so I removed it ahead of time. Here I have a modification. This is why I'm showing this video. If you're familiar with a normal laser pointer lens, they're like this. Just a 9mm barrel holding a 6.3mm diameter, usually aspheric lens in it. It doesn't have to be an aspheric or aspheric. That's what's normally put in. Problem with this is the focal length on these small lenses are typically fairly short. The longest I've seen is an 8mm focal length. The shortest I've seen is 2-point-something millimeter. That would be the G2. The 2 must denote that. The G8, which this is, would be 8mm focal length. But with that short of a focal length, with the NUGM04 diode I have inside this, it's fat corrected, by the way. That diode was fat corrected after being manufactured by a third party. And the beam turns out to be so tiny with this small 8mm focal length lens that the divergence was huge. It was way too high. So my thought was, well, how am I gonna adapt this? And I came up with some ideas and found some things on eBay that I could use for a longer focal length, wider diameter lens, which you see on top here. That's a plano convex. I found the copper end feed reducing coupling for copper pipe. It's for something to do with gas, water, oil. I don't know. I guess for any of those three. Chinese. I could not find these in the United States. This seller has various sizes you can select. They're all out of the one that I bought, the 12.7 times 8mm. It's out of stock. But that's the one I bought. So on this end, the ID is 12.7mm. Here's one loose. The small end, the ID, is 8mm. Well, that's perfect if for you could thread, use a tap and thread for this small 8mm focal length lens, which I'm not using. But a lot of the other lens housings we can buy, I bought this from Tech Hood. This is what they call a half thread. They're also, at least the end with no thread on it, that is exactly 8mm OD. That allows me to fit this straight onto the top. It's a pretty tight fit. I'm not going to try to get it because I'm holding the camera or my phone with one hand recording this. I can't get it on straight to show you, but it's a nice tight fit, not too tight. You can get it in by hand. Okay, I did that, and then I had some lenses I bought surplus on eBay some time ago. This particular one is no longer, the part number on it is no longer being sold on Edmund Optics. But if you do look for a lens like this, this is the 15mm diameter with this 30mm focal length. Well, it's also AR coated. This one is. You could put that right on top. I should take that all apart because it's just going to fall over. You could put a little bit of glue That's what this pen is. I found this on eBay pretty cheap. It's called a 5-second fix. And you can squeeze out a little bit of glue around the rim, the top rim there. And then this, they call it a UV LED. I don't know what wavelength it really is, if it's technically really UV or not. But it does cure that glue really fast. It is, I believe, 5 seconds is about right. So if you glue that top there, the copper, and then put the lens on, and then you can use your light on it all around the edges of the lens where the glue meets it, and then shoot through the lens itself, and it cures it pretty fast. So once you got that lens on there and slid on to this half thread barrel, 9mm, they call it a 9mm barrel, then you can use it like I have with this pointer host or laser diode host, and use some Teflon tape in the threads. It makes it more stable when you're tightening it down. A little piece of heat sink material. That's a 12mm DTR module that it's threaded into, by the way. I'll go ahead and turn this on. Probably going to be entirely too bright to see the beam well, but it's expanded quite a bit. Yeah, it's all washed out in the lens, but it is a rectangle shape. It takes up like 80% of the diameter of the 15mm lens. You can kind of see the diameter of the beam there. I can turn off the light, it'll be a little better. But as you can see, I get something dark behind the beam. It's really expanded. Now that's the wide side. This diode, even with the FAC lens, the thin side or the slow axis is quite a bit thinner. And that's why it's a rectangle shape. The FAC doesn't quite do it for making a square shape like is advertised on eBay. It will if you don't collimate it, it's square, but if you collimate it, it's a rectangle. But it does help reduce the fast axis spread, so I was glad to get it. I better be careful, I'm gonna make a mark on my ceiling. Better move it, turn it off. Okay. I'm gonna set that on its side. All right, we're 8 minutes into this, a little longer than I was going to do. Lifetime17, a member at Laser Pointer Forums, did a great job on this. He had sent this to me without, like I was saying earlier, without a lens or anything. With this kind of a setup, you could easily knock that. It's glued on really good, it won't shake loose. But you could knock it loose and knock the lens off. Or the copper, for that matter. I suppose if you hit it hard enough. That's why I bought this. It's a little thick and a little heavy, but it does the job as a lens guard. So if I press that on there really well, it's a really tight fit. It really needs to be a 1/4 millimeter wider ID inside. I could push it all the way down. It's okay. I could push it all the way down, but then I'm going to cover up my little Allen wrench hole here to be able to pull out that 12mm module, which might be trouble, and I don't want to have to fight to pull this off. So for me, that's good. I just need to keep it from knocking that lens inside loose. Plus it does serve a bit to add a little bit of heat sinking. Brass is not ideal at all. Copper is what you want. I thought about having a copper guard made for it, but those dent so easy. I just thought I'd go with the brass since it has enough heat sinking. Normally I like pointers with fins. If this were carved for fins, that would be more efficient for heat transfer, but it does okay without the fins. And actually, as much as I'd always said in the past, I want fins on all of my copper heatsink or aluminum, I like this one without the fins. And it won't get dinged up so easy because copper is very, very soft. Anyway, to talk about that modification a little more, I bought some lens holders from Tech Hood in China. They have things you can get there that are really nice. Unfortunately, we got something not so nice recently from them, but that was Wuhan, that wasn't Tech Hood. I already have a finished unit here, the same as it's in the end of this pointer, and it has a biconvex, I shouldn't call it that, biconcave lens inside the end closest to the diode. So you can buy those from Edmund Optics. I pulled up the page. You can get them in different sizes. The one that worked for me, I bought 3 different sizes to see which one would work. And this one here, the 6mm diameter, of course I bought all 6mm diameter because that's what fits inside these lens holders pretty well. And the 12mm focal length was the one that didn't spread the beam too much. I tried a 6 and I tried a 3, and they spread it way too much, and it was way too wide, and I was losing a lot of the light before it could even get to the lens. It was truncated or cut off inside the lens holder. So if you're going to do this with a 30mm focal length lens like I have done with this adapter, you want the negative 12mm focal length. And these are AR coated. The best AR coating you can get right now is the Vis Zero. I would go with that. It has the least loss. A little more expensive, but the least loss. But back to this lens holder I got from Tech Hood. What you would get is, here's one without a lens in it. What you would get is this lens holder, a grommet, a little rubber grommet to fit in this little groove in the middle, and you would drop the biconcave small little lens in there as a beam expander. Then you would drop this little barrel on top of it to hold it in place, and then you would thread in this last piece all the way down, and then you would have a beam expander assembly. No collimation, it just makes the beam wider, which was necessary for this particular diode, because otherwise the spot was entirely too small and the divergence way too high. And that's why I built this, because I wanted a low divergence pointer. So you put that on, and then you have the focal length you need. If it's, what you could do is play around with it, glue the lens on here, and thread this in and out. Try to find where infinity focus is at. With this lens, this little coupling was just a little bit too long. I took off about a quarter of the length, this smaller barrel with a file, and then I could find the infinity focus for it and put it together. Here is 8mm is more standard lens that you can find on eBay with a little knurled knob so I don't burn my fingers when I'm trying to set focus. I just brought that out to show it. I had one of the, well, that's what this finished one is. It has the -9mm focal length biconcave lens in it, which didn't work out. Anyway, that's a way you can use a 9mm barrel or lens barrel with a standard that normally used with a standard lens, with a much wider 15mm diameter lens with a much longer focal length. That's all I have to share on this. There's another video on Laser Hobbyist YouTube channel showing this outside. It's under NUGM04 without the sleeve on it here. And 1.5 watts of green, 520 nanometer is wonderful. And when you have expanded the beam, the divergence is really good. This one worked out to a fairly low divergence, and you can look at that video to see more about it, or in the text of that video. Okay, cheers.